All right, last part. So this is the part that I barely talked about in the end of class. So we have a particle that is moving along a coordinate axis in the positive direction to the right. So they're telling us to the right is positive. Its position at time t is given by the following function, and it's cubic. So that means this particle is like going to the right. At some point, it's going to stop, go back to the left for a while, and then stop and go back to the right. It could also just like go to the right, slow down, stop, and then keep going to the right. But it will definitely start from the left and end on the right, and we should see a little bit of wiggle back and forth. Otherwise, it's a boring question. So, is the particle moving from left to right or from right to left at time t equals 1? Is the particle speeding up or slowing down at time t equals 1? So, to answer which direction it's moving, I need my derivative. To answer if it's speeding up or slowing down, I need my second derivative, acceleration. So, let's go ahead and take our position function. S of t is t cubed minus 4t plus 2. So S prime of t, which is velocity. So the derivative of t cubed, so that is power rule, the 3 comes down, and now it will be t to the 3 minus 1, which will be 2, minus 4, and then times the invisible 1 comes down, and t to the 0, plus the derivative of just a constant, flat line. Flat lines have 0 slope. All right, so our v of t here is 3t squared minus 4. So I can figure out v of 1 is 3 times 1 squared, so it's 3 minus 4 is negative 1. So if v of 1 is negative 1, then is this going to the right or to the left? They told us positive direction was to the right. This is a negative velocity, so it is moving to the left. To the left. All right, now we got to answer the acceleration question. So let's backtrack over here. And our acceleration is the derivative of our velocity. So we have 3 times the derivative of t squared will be 2t to the 2 minus 1, which is 1, so I'm not going to write it, minus the derivative of 4 is now a constant. So now its derivative is 0. So the acceleration is just 6t. So it is not a constant acceleration. This is an acceleration that changes based on our time t. And our a of 1 is 6 times 1, which is 6. So let's backtrack back to the question. A of 1 is 6. So now is it speeding up or slowing down? So it's moving to the left, moving backwards, but the acceleration is positive. So they're arguing, moving backwards, acceleration. So we are slowing down. Now, kind of like the previous question, we found a snapshot and answered some questions, and then they said, all right, well, where is it increasing? Where is it decreasing? So now it's going to say Here is even uglier function, sorry. Totally new one. But we only concern ourselves from 0 to 4. Find the particle's velocity as a function of t, and then determine the open intervals on which the particle is moving to the right and to the left. And it says moving along a horizontal coordinate line, so something like the x-axis. So then we assume to the right is positive, to the left is negative. All right, so our velocity function. So remember, velocity is the derivative of position. So this will be 4 times the derivative of t to the third becomes 3t to the second. Then our constant multiple, negative 26 times 2t to the first plus 51 times 1t to the 0, which is all just 1 times 51, plus 0. So v of t is 12t squared minus 52t plus 51. That's ugly. So we want to know, when is it moving to the right? When is it moving to the left? So that's asking if I can tell where it pauses to turn around, or just where it pauses, where the velocity is 0. So now we have a quadratic equation that's equal to 0. We can use the quadratic formula to solve. Or you can just trip over to Desmos, have it do it. I am not as proficient in Desmos, but I will save you guys the time and effort on most of the calculating. So, I still got to write some of it though. It's just the way my brain works. 52 plus or minus the square root of 52 squared minus 4 times 12 times 51 is 256. Ooh. $256 square roots nicely. It's actually 16 all over 2 times 12 is 24. So we still should still get like decimals that aren't awful though. 16 plus 52 is 68 divided by 24. All right, so we have t is 2.8333 repeating. And then 52 minus 16, 36 divided by 24. Nope. 1.5. Okay, so those two t numbers are where this turns around. So what we're going to do here is we're going to draw a number line and we're going to actually mark what's going on it. So here is our number line. So we start at 0, we go to 1.5, then we go to 2.83, and then we go to 4. We don't care what it does before 0 or after 4, but this region we do need to care about. So what we want to know is, where is the velocity positive? Where is the velocity negative? And that can be a little tricky to figure out just by looking, especially if we get a function that's even uglier. But what we can do is pick a test value and see what happens in our velocity function with that test value. And for this first region, Well, we got 1 is a lovely tester. So 12 minus 52 plus 51, that will be positive. So whatever the tester is, since the marks are our zeros, the regions between our zeros, it's either all positive or all negative. Because if it was going to be a mixed signal, there'd be another 0. All right, between 1.5 and 2.83, we can test 2. This will be a little uglier, so crunch, crunch calculator. 12 times 4 minus 52 times 2 plus 51 is negative. And then after 2.83, but before 4, so we can test 3 now. So 12 times 9 minus 52 times 3 plus 51. And we get positive 3. So over here, plus, 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 plus. So the open intervals on which the particle is moving to the right, which we assume is the positive direction, and to the left, which we assume is the negative direction. So we are going right from 0 to 1.5. And then WebWork has you just put a comma, and then our other part of the answer is 2.83 to 4. Like mathematically, when we write two intervals, we usually stick it together with a union symbol. But, whoever programmed WebWork didn't want to deal with unions. Then our particle is going to the left on the in-between, the 1.5 to 2.83. All right, now we are going to use that information when we answer our next one, because the next one is now same function as before, but talking about the acceleration and the open intervals on which the particle is speeding up and slowing down. So to answer that, we have to know when is the acceleration positive, when is the acceleration negative. All right, so our velocity function was 12t squared minus 52t plus 51. So now our acceleration will be 24t minus 52. Now to tell where it's changing signs from positive to negative or negative to positive, whatever it does, we set it equal to 0. And we end up with add the 52, divide by the 24, which is 2.1666. Okay, so our acceleration, if I go ahead and sketch that one, we have our start at 0, our end at 4, and then at the 2.166, that's where acceleration changes from positive to negative or negative to positive. Now, since this is a positive slope, it's going to start negative and then go positive. But we could pick test values. So like t equals 1, 24 times 1, 24, minus 52 is going to be negative. And so over here, if we plug in 3, 24 times 3 is 72, minus 52 is positive. And it can be very tempting to okay, negative slowing down, positive speeding up. No. Whether we are slowing down or speeding up is dependent on the velocity interacting with the acceleration. So we actually have to correlate these two number lines. And through the magic, of the computer, sure. I now have both of them, one on top of the other. So we are going to make a kind of like master timeline here, where we are going to consider all of our points. So we have our 0. The next number is a 1.5, then the 2.166, the 2.83, and then the 4. Let's go ahead and go with some labels. So this is velocity, this is acceleration. So from 0 to 1.5, our velocity is positive, our acceleration is negative. So they are opposite signs, so this is slowing down. Now from 1.5, our velocity flips, so it's negative now, until we hit the 2.166. Now they're matching, so now it's going to speed up. Now our acceleration has changed direction. So we're cruising backwards, but now acceleration is like, whoa, whoa, whoa. Let's try to go forward now. So the acceleration is going to work to slow down the velocity. So we slow in this next stretch. And then finally at the end, they're both positive. So now it is smooth sailing off to infinity and beyond. So the open interval is when it's doing one or the other. So we're slowing down from 0 to 1.5 and from the 2.166 to the 2.83. And then our speed up is the other stuff. So the 1.5 to 2.166 and from the 2.83 to our end value of 4 as described by the original setup. So I know setting all these number lines can feel like a lot of extra work. We are going to be using these number lines several more times in slightly different ways. So it is a good idea to practice it now, get used to it now. This idea of where are my values that are zeros? What is the graph doing in each of those regions between zeros now? Whew. Last slide is just our summary slide in a lovely rainbow. And it is 12:27 in the morning, so I'm going to stop now.